So Alvaro is going to show you plenty of RabbitMQ simulation. What does it do? What is queuing? And how RabbitMQ actually makes things happen. And then we thought we would live code a bit of an app together. So this is probably the only talk at Spring 1.2 GX where there is no Java. So we will show you RabbitMQ. We will show you JavaScript with a little AngularJS app. We'll be doing SockJS, WebSockets, Stomp. We'll be writing some Scala. We'll be writing some C++, some iOS. Sadly, if anyone wants to see Java, there's the door. But I hope you will like it. You'll enjoy it.
Stay here.
Stay here, absolutely. We don't want to get rid of you. If you have any questions, it's going to be a lively session. We'll be asking probing questions. And then we have a final demo that we, of course, welcome you to come up and try. Unfortunately, we couldn't get the Wi-Fi running, so we have a small little access point for a few devices set up here. So you won't quite see the whole. We could probably handle all of your devices on a MacBook Pro. But anyhow, we'll have to try with a few. So let's start. So this is me, Jan Machacek. I work at Cake Solutions. I've written ProSpring 2.5. If anyone has them, they're out of date. I'm really sorry. Lately, I've been doing plenty of Scala. So on the Spring side, that might interest you is Specs2 Spring, which is a BDD framework for BDD testing framework, rather, for Spring Framework based on Specs2, which is a Scala piece. So if anyone wants to venture out into Scala but doesn't really want to write the main portion of their code in Scala, this is how you keep it isolated. Just the test, no need to worry. I edit the open source journal, which is a big thing in Europe. Unfortunately, we couldn't quite get the copies shifted over here. Last issue that we printed came in at 5 metric tons. So it was a bit difficult to sort of have it flown over here on United. They said no. My Twitter, email, and GitHub. So that's all the important stuff. And then we have the man himself for RabbitMQ.
So hello, everyone. My name is Alvaro Videla. Don't try to pronounce my name. Even my sister couldn't do it when I was a kid, so don't worry. I'm a developer advocate for Pivotal. I work also with the RabbitMQ team. I'm the co-author of the RabbitMQ in Action book that we'll be giving away today. So let's keep it somewhere here so we don't forget. I'm the creator of the RabbitMQ simulator that I will be showing later. And recently, I started blogging about RabbitMQ internal. So if you like to know about how RabbitMQ uses Erlang, that's the place to go. There are not much stuff there, like about 5 blog posts plus some related GitHub projects. But anyway, that's interesting if you like Erlang. And yeah, that's my Twitter account. I'm known for tweeting too much GIF images, so if you want to follow. But anyway, and my email if you want to reach me at Pivotal, and my GitHub account. So probably 20 out of 15 projects are about GitHub, so about RabbitMQ, sorry. Anyway, to start the talk, I always like to ask, why do we need messaging? Because it's very nice to say RabbitMQ is the new king, blah, 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 but then why should I really be listening to you here, right? So I always came from a very simple example for a very simple web app, but nonetheless it's worth for the discussion. And the question is, if we have to implement a photo gallery, and they tell us that it needs to have 2 parts, the upload picture section and the image gallery at the end. So we tell the product owner that this is pretty simple, that we can get it done soon enough, until we start getting new requirements as usual. If you had one software project that never had new requirements, I don't know, what was that? So we have the product owner that comes to us and says that they want to notify the user friends whenever there is a new image. And of course, because this has business value, they need to have this for tomorrow, as usual. Then somebody hired a social media guru. It happened in a company where I was working. And they have to give badges to users for each picture upload. If you remember the first square times when everybody was tweeting, I'm here right now, and because they were tweeting, checking in every location, they were getting badges, so we were being spammed, so somebody else got something. And also, this has to go onto Twitter. Then we have a sysadmin, as I like to say in Switzerland, we have Swiss admins, and those guys come to us and say that we are delivering full-size images and that the bandwidth has tripled. Even this sounds dumb, but we actually did that with video delivery back in China, and they were not liking us. Because, yeah, you can imagine how much money the bandwidth bill was at the time. And of course, this had to be fixed by yesterday, else the CFO will fire everybody. Then we have a developer in the other team, and he needs to call our Java stuff, but from Python, because, I don't know, Python is cool now. And also PHP and Python, and needs to start mixing all the stuff. Also, everything has to be for today. Then at some point, we have the user. We usually forget about the users. Somebody came to us and said, we need to have this new feature. We go, code monkey, ship, deployed. But the user really doesn't care about that it has to wait, that the image has to be resized or tweeted or I don't know what. If I'm a user, I go to your website, you're advertising that you can upload images. I just want to click upload, see the image there. I really don't care if you're paying too much bandwidth, your problem. You offer this free service, not me, and so on. And we usually forget about that there is somebody else on the other side that maybe this feature is destroying his user experience. And then it's us, at the end of this story, we're just flip tables and like, I don't work here anymore. I had some other words there, but I had to tone it down. Anyway, let's see the evolution of the code. I will be using pseudocode that is actually the way I can sneak some Erlang into the conference. That's just Erlang syntax. That's the comments, the function name, the arguments, and the body. Plus the return value. That's how Erlang works. It's just a functional language. The last expression will be returned. So the first implementation of that thingy was we get a new image. We have an image handler. It will do something with that image, put it in a database, move it to some place in the file system. I don't know. But let's say that's the whole controller. But at some point, of course, we have to resize the image. So we place that thing there. Later, we had to also notify friends. So we also went there and added this. And also add points to the user. Each of those changes required a new deployment, for example. Every time we had to add something there, new deployment, restart the server, whatever, get it updated, basically. Then we need to tweet a new image. We also need to stop, deploy again, and so on. The question that this code brings up is, can our code scale to new requirements? What will happen if we need to speed up image conversion? If you have just like a monolithic controller, what will happen is that you need to deploy more instances of your app just because you want to speed up image conversion. So what happens if the notifications need to be sent by email? We need to go there, modify something, deploy again. What happens if we need to stop tweeting about new images? Let's say Google decides that it's cool to have social network. There is a new social network there, and we need to use that instead of Twitter. I don't know. It may happen. Then we need to resize the images in different formats. Again, some new deployment changes, whatnot. We may want to swap the language and the technology without any downtime. Later on the demo, you will see that we are mixing a lot of languages for a reason, because there is like the best tool for the job, and maybe for resizing images, some language will be much faster than other, and so on. And yeah, you can see there are a lot of questions that this kind of architecture like a vanilla, no messages, very simple controller, which probably most of the usual Rails app, PHP apps, and so on, they are implemented that way, and they have a lot of possible problems in the future. The question is, can we do better? And of course, I'm here to sell you messaging, so the answer is usually messaging. And actually, this can be just solved by a very simple pattern called publish-subscribe, where this is from the Enterprise Integration Patterns book that was mentioned yesterday by the guys from eTrade. You have a publisher. In this case, in the book, they have an event called address change, goes into a channel, a pub sub-channel, and then you will get each subscriber doing whatever it like to do with that event. And that's it. It's very, very simple, very basic, but usually, I don't know why, or sometimes we forget about that. So the first implementation of the controller will be, we move the image somewhere after it's uploaded. Then we create a message. There I'm just using like a user record, which is like a map user will be the information, image, the extra information. And this is published using a tag called new image. It's very similar to how you do stuff with Node.js, or maybe yesterday they talked about Reactor having events, nothing new. So we have a process that is on new image, notify friends, another one, points manager on new image, add points to the user, and then finally resizer. If we need to scale any of those processes, we can just add more instances of each of them, but not all of them, as it used to happen with the previous implementation. If we have a burst and there are too many users at certain time in the day, then we can have, let's say, more image resizers and stop them at night. We can save money. We can fire up more instances on Amazon of our app, and then put them down at night, and do all this kind of scaling stuff, just by using a very basic and simple pattern. And even if this sounds like way too basic, in like about 2 weeks ago, I was in Salt Lake City, and I had a meeting with a professor from the university, and he was asking like, okay, we are preparing the students to be able to go and join the startup frenzy, right? And do they really need messaging? When you just need to get the product out of the door, why will you even care to install something like RabbitMQ? Wow, what that will be. But if you think about that, by using this kind of architecture, actually you can get a very fast way of adding and testing features and swapping them, changing them. Don't need to have downtime if you prepare everything, of course. I mean, there is nothing for free, but it will enable your company to be much more flexible. And even like teams that can only focus on one part, really optimize that, where we need to have speed, where we don't care, we can have something that runs. I mean, I'm talking from the like a startup point of view. We should care every time, right? So what's the second implementation? There is no second implementation. That's the first one. It's all there is to it. So the second question is, what is RabbitMQ? Because we say, okay, we can use messaging, RabbitMQ is a message server, blah, 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 but what is actually RabbitMQ? So it's a multi-protocol messaging server. It's open source under the Mozilla public license, so it's there to use for free. You can change it, modify it, send pull requests, and all the stuff. It's polyglot. By that, it has many meanings, actually, because with Rabbit, you can use, you can connect to it from many languages, thanks to the protocols. And if you want to implement stuff like extend RabbitMQ with plugins, you can actually use Erlang, because it's implemented in Erlang, or Elixir, which is a new Ruby-like language for the Erlang virtual machine. If the Elixir guys are seeing this talk, I'm sorry that I say Ruby like, but they don't like it, I know. Anyway,
it is fantastic though. It is really,
it's really
good.
cool and it really looks like Ruby. But please
right.
edit this part from the from the video. Now we can continue. It's written in Erlang OTP. Why do I care? I mean, I paid for a Spring conference, and you are talking Erlang, 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 Erlang. So why do I care that it's written in Erlang? It's because besides all the history known from the telcos in Europe using Erlang and whatnot, the OTP framework, which is called a framework I learned at Erlang conference recently, because they need to sell that to management. They had to come with 3 letters, like an acronym, and have the framework in there, so management will accept that into Erlang. Actually, the OTP framework are just patterns on how to do messaging and fault tolerance into Erlang. So the good part of that is that all the stuff is implemented in Erlang. The RabbitMQ guys don't need to work on that, so there is less code, less bugs, and stuff that everybody is testing, even if they are not using RabbitMQ. So when we choose RabbitMQ back then, one thing that for us was a big win was that all the concurrency and fault tolerance and stuff was built into the language. The Rabbit guys didn't have to implement that, and yeah, it's better. I said multi-protocol. By default, or RabbitMQ started as an AMQP broker. AMQP stands for Advanced Messaging Queuing Protocol. Then Stomp was added, and also MQTT as plugins. So MQTT is a very low footprint protocol. It's used, for example, by Facebook for their iOS chat application. It comes from IBM. It's made for low battery and low resources devices. So if you have sensors, they will be using that protocol. And Stomp is a text-based protocol, very similar to, I mean, not very similar, but in a sense like Redis, the Redis protocol, where you just have like header, end of line, new header, end of line, message content, and quit. So that's the whole protocol. For example, when CERN, the lab in Europe, in Switzerland, I visited them because I live in Switzerland. We discussed about how they were using Rabbit, and they are using with Stomp because they have many sensors, and having a client in Stomp is very light, like, I don't know, probably 10 lines of code or even less, I don't know, because it's very, very basic. Anyway, if you want to know more about the protocols, there's a discussion by a colleague from Andy Piper. He describes in that blog post why you would want to use one protocol or the other. I say polyglot. So we have Java, Node.js clients, Erlang, PHP, Ruby, .NET, Haskell, and many more. The thing is, the Java client, the Erlang client, and the .NET clients are officially supported by the RabbitMQ team. So if there are new things on Rabbit, those clients should have them. I maintain the PHP library, and the guy that maintains the Ruby library works also for the RabbitMQ team, so you can trust, for some definition of trust. You know who to blame if you use PHP. And yeah, Rabbit can be accessed even from COBOL. So from people out there, they are using that. So I even got asked once that, is there anybody using this RabbitMQ project of yours? Yes, Instagram is using Rabbit. Indeed.com is using Rabbit. Mailbox app, this application that got acquired for an incredible amount of money, is using Rabbit. Mercado Libre, they were here last year, and there are some guys here, I don't know if they're in the room, but this is like the eBay of Latin America. When I say Latin America, think Mexico, Brazil, Argentina, Chile, all those big populated countries, all going to Mercado Libre. Of course, also Uruguay, where I'm from, that's the most traffic coming to that website, and that's why they need Rabbit. Anyway, there are real users of Rabbit. Also, you saw yesterday E-Trade, for example. We have Jess from ADP here using Rabbit, so yeah, it is used. It's weird that I have to say that, but I even had the question once, so let's dispel every myth. And if you want to download it, that's the place to go. The only dependency, because it's written in Erlang, you need the Erlang virtual machine. Like if you have a Java program, you need a Java virtual machine. That's all. But then it just runs. So how do you do messaging with RabbitMQ? I will do a short demo with the RabbitMQ simulator, and you can get it there on GitHub or submit pull request or whatever. This is a simulator. It's written in processing.js. People ask that, what is this implemented on? It's in processing, which started as a Java framework, and then John Resig from jQuery rewrote it or ported to JavaScript, and is official supported. Anyway, into the messaging bit. When we do messaging, what we have is that we have a producer and we have a consumer. Let's please work. What's going on? So the whole goal of messaging is to get data from here to there, right? How do we achieve that? We need an exchange. The exchange in RabbitMQ is kind of the address where you send messages. So you will tell your producer, connect there, and send messages. But nothing happens, the message disappears, poof. Why? Because we need a queue. That's the queue part on the RabbitMQ name. We get it there, bound to the exchange. That's the terminology. So once it's bound, we send messages, and we can see the start queue in there. Very nice. But still, the message is not in the consumer. What the consumer has to do is to subscribe to the queue. So when I subscribe, I start getting messages. But they are just going there one after the other. What RabbitMQ will give us for free is that we can do round robin. So I can have more than one consumer, send many messages, and they will get there. Those consumers can be in the same server or in different servers. If you can connect to Rabbit, Rabbit will take care of doing the delivery of the messages. Now you may ask, why do I even want to have an exchange? The whole point of the exchange, I mean, why don't you just send the message directly to the queue? The whole point is that imagine you have an email inbox, and then you tag messages, and depending on those tags is where you file them in different folders. That's what the exchange can do or does. So if I have a new queue here, for example, I can also send the messages to that particular queue. So this is a very basic pub/sub thingy. But then, if we go to the exchange properties, we see that is, I don't know if everybody can see, but it's a direct exchange. What that means is that there are actually 3 different routing algorithms. There is even a 4th one called headers. There is fan out, there is topic, and there are even plugins that add more exchanges to RabbitMQ. So because it's a direct exchange, what will happen is that whenever we publish a message, the routing key has to match. So if I have ASDF change, I have that routing key in the binding from the queue to the exchange. If now I send a message, they won't get there. Why? Because the routing key doesn't match. On the first one, I say binding key because the default one is an empty one. If I have something empty there, you cannot see it, right? So if I change it to HDF, then it goes to that queue. Very simple. So if you want to do direct messaging, the direct exchange is the way to go. You just filter by routing key. But you may want to not use routing keys at all. So you can have a fan-out exchange. And routing keys will be disregarded. So whenever you send the messages, it will go everywhere. Our use case could be that we have here the Twitter consumer, and these ones, because we have probably more work to do, are the resizers. And so on. So that's the fan-out exchange and how we could implement what we had in the example. The question I always get, like, yeah, that example is very naive. It's not checking what, because you maybe want to tweet once the resize is done and so on. I mean, that's for sure is something you want to have. Then this resizer can also publish the message into a new exchange and form a chain of messaging and hops, like a bunny. Finally, we have the topic exchange. What's the point of this one? Let's have a producer. Let's have a queue and the consumer. So I send a message, direct exchange, basically. Then I can have a queue here where I actually want to have, let's say I'm listening from server 1. I'm sending logs into the exchange, server 1, app 1, info. What I'm saying there, this queue is only interested in those kind of messages. I can change the exchange to be actually topic and to be logs. So I send the message again. It won't go down there. Change the routing key, server 1, app 1 info. What's going on? Yeah. You were paying attention. That's what the teachers always say, right? It's never their fault. Yeah, thanks. And yeah, it's just like whatever, dude. I mean, nothing impressive so far. But what we could have here, I can edit this binding and say, I don't care what's the server. I do care that it's from application 1, and I do care that there are info. So I can change that. Come here. Then the message goes both places. But if I change the server on the publishing side, it will go only up there. I can even have a new queue where I say will be, I don't care the server, has to be app 1. I don't care the error or the log type. Change, come here, error. It will only go there. And finally, if you don't want to do all these matching thingies, the final special character, let's say, is the hash. So I can say hash and info, for example. Change. I send it, it won't go there. I put info, send, it goes there. I change to app 2, send, it only go in that one. Because the hash, it matches 0 or more words, and the star only matches 1 word. The patterns, as you can see, are words separated by dot. So that's all there is to it. You have these words, dot, next word, dot, and so on. If you put a hash on the binding key, then you will match more than 1 word. And if you put a star, you will match only 1 word. So those are the 3 main routing algorithms that RabbitMQ implements. Just a small detail about the simulator in case you want to use it. All this stuff you have here, if you have a running RabbitMQ server, you can export this architecture and it will be put into Rabbit, so you can use this as a designer. If you click import and you have the running Rabbit server, it will import everything you have there, draw it there so you can debug. You can put a consumer and a producer, click send, change routing keys, and see what's actually happening. So that I think is very helpful. And later I created also like this 2-player thingy. Will give you like a JSON stuff from what you have there, and Not sure if this works, but player. Yeah, you can do documentation for your projects saying, this is what this part of the app is doing, this is what the other part is doing, and so on. And I know companies are using this for teaching the new recruits. And as I said before, it's on GitHub. So, any questions? Yes?
Is there an administration interface or GUI for RabbitMQ?
Yeah, there is one. It's called the management plugin. It's another plugin, and it comes by default. You just need to enable it. So you install Rabbit, and then there's a command like RabbitMQ plugins enable management, something like that, and that'd be it. So, because you asked the first question, the book is for you. Please. There. That's the trick. I don't do so many talks here in the States, so people don't know, but every time the first question gets the book. So sorry, I never tell the trick. So continuing, we will go with Jan.
Yeah, absolutely.
Thanks. So
switch. We've seen the comfortable part of the app. No, actually, it was very impressive, and the demos worked, which was great. Let's code it, right? Let's write something that actually does it. So we're gonna do a computer swap and see how that all works. And I'll show you exactly what we are going to build and how that's all going to work together. So here we go. Thank you. Blank keynote again. That's jolly good. Right. So you can see the props, right? We have iPads and iPhones and completely random member of audience that we've selected in advance. I won't tell you who it is, but you'll see that in a minute. So here's the thing that we're building. We would like to build an app that can count coins. Quite simple, right? This sort of thing. So if I give it a picture of 2 coins, it should draw me 2 coins. Nice and easy. 3 coins, and so on. So exactly what humans would do. This is easy for us, but we had billions of years of evolution, so that's kind of putting us in an advantage. But images are a bit boring, right? This is 2013. Let's do video. So what we're going to do, in fact, is this. We're going to record a video. We're going to stream it from the iOS device over WebSocket, raw binary WebSocket, to a Spring app. We're going to send the messages through Spring integration to RabbitMQ. We're going to write some C++. So if anyone remembers segmentation faults and pointers, hands up. Yay, great, fantastic. Right, so we'll be doing that. Has anyone done OpenCL? Excellent, we'll be doing that as well, just for good measure. Well, that's about it, really. AngularJS app, we'll hack it together in Scala because, quite honestly, we have 50 minutes. And it's a tall order, 50 minutes, computer vision app. How hard can that be? So let's get going. This is what we're building. An iOS phone, iOS 7 beta, right? So I shouldn't tell you, but this is running iOS 7 beta. It worked yesterday, so it'll be fine today. Oh, no, you shouldn't have told me. I will watch that on the plane tomorrow. If anyone tells me what Apple announced yesterday, they're in trouble. You will have ruined an hour of my life on the plane. Anyhow, iOS client talking to a Spring 4 app. This is Spring Framework from last Wednesday, so really, really latest stuff. We'll be running in Jetty, talking to WebSockets. We'll be using the Spring integration AMQP, so it's going to be a very, very simple message chain, Spring integration chain. We'll be doing OpenCV, so this is a C++ library. What's going to come in? Well, okay, some MJPEG stream, blobs coming in towards RabbitMQ, the binary, the message data, which is great, and JSONs going back. We won't touch the JSONs. We'll just take them as we receive them from the C++ code, send them over to the web app, and we'll have some sort of HTML5, AngularJS, interesting app, mainly because I can't do HTML, and AngularJS is actually pretty reasonable. All right, so let's do it. This is roughly the core of it, right? We have the recognition service, and we are submitting these chunks, so the bits from the device. A bit of data is going to come in, so it's going to be a chunk of data. And we'll generate a correlation ID, a session ID, if you like, because we'll have multiple sessions at the same time. So we need to know which session is sending us which images. And chunk data, some array of bytes. That's the thing we've actually received. We return back a unit, which is this sort of type and a value, one thing, like void, but with a capital V, but actually much better than void. Anyhow, I get distracted. Then some magic and ponies and, you know, whoever. I like it. I'm pretty good. I was really pleased with that. And record service activator, that's when we receive a message from RabbitMQ. So we will send a message out. RabbitMQ will do the computer vision, or rather the C++ code at the end of RabbitMQ will do the computer vision stuff, reply back with a JSON, and this will happen. Now, we will write a command line app that just prints it out, and then we'll do the web app that sends it over WebSocket, right? How hard can that be? So let's do a demo, right? It's easy. We'll start with this. This is the actual chain. That's the unicorn. The record service at the top, we will send messages to a direct channel, which will then send it to a Spring integration chain that we'll type up in just a second. So what are we going to do? Well, chunk data, and we need to split it. So we have a chunk decoder. That's the first thing. Because a block of data, right, in a video stream might actually give you multiple frames. And we can only deal with a frame at any one time on the image processing side. So we split them. So we go from chunk data into a collection of frame data. So Spring integration people in the room. Yes, hands up. Yay, fantastic. So it's easy to split a collection, a message whose payload is a collection of things, into multiple messages. That's already prepackaged in Spring integration. So that's the default message splitter. So from the collection of frame data, we'll have multiple messages, each containing frame data. They go over the AMQP outbound endpoint. It's a bit of a mouthful, but one of the protocols of RabbitMQ. We send it out to a direct exchange. We talk to a specific queue. And we will actually create a temporary queue just for the reply. So this is quite a funky thing. We send a message out directly to a specific queue that has a consumer at the other end. But we want to receive a message back from the consumer. So what we are going to indicate to that consumer for that particular message is where does the reply go to? This is brilliant. So it's really nice and easy. It's still direct communication from Java to the C++ code, from the C++ code back to Java, specific mailboxes, if you like. So we receive array of bytes. That's AMQP, you know, it's just arrays of bytes. We turn it into string even, because we know it's a JSON, and we take that string and sort of shift it over either on the command line, or rather on standard output, or on the web, and that will be the job of this guy. Right, enough talking, let's code. So what I have here is a blank project. I have ways to cheat, so don't worry. So what we're going to start with is the basic definitions of the things that we're dealing with. So things like the services, right? So we have the record service, which is this guy, and a record service activator, and the few domain objects that we are going to be using. All right, so let's begin with that, right? So in here, where we have the requests in the package, what we're going to create. OK, just so we know what these type synonyms are. We said there was going to be a coin response. There's going to be a frame data and an image data. So what are they, right? So this is going to be really nice and easy. Image data is simply an array of bytes. And type frame data is array of byte. The reason why I do that is because I don't like typing. And I like these as synonyms. So if I say frame data and image data, the bytecode that the Scala compiler will produce will be indeed array of bytes. But I can use it in my code, so I don't have to have that many square brackets, essentially. You know, imagine a collection of square bracket array of square bracket of byte. Just looks ugly. And finally, coin response will just be a string for now. So that gets us going, right? That's the first start. And then we have our record service. So we have the two methods. So this is the thing where we submit the images. So we will submit an mJPEG chunk, and we will submit an image chunk. Let's do just that. Chunk. That wants, what does it want? It wants a correlation ID. and it wants a data, which is chunk data, which I forgot to say, unit. Did I have chunk data? No, of course not. Chunk data, very good. Like that. There'll be some weird implementation. We'll see what that will be. We'll have an image chunk taking the same thing. Correlation ID and data, chunk data, returning a unit. Any Scala fans here in the room? None. Oh, that's depressing. That's really terrible. So what we're doing here are curried methods. Does anyone like curries here? At least that. Come on. There's one. Yeah, there we go. Fantastic. So these are curried methods. We'll see how useful they will become in just a minute. If anyone's done Haskell, or dare I say Erlang, you'll be fine with those as well. Alrighty. So we're missing this correlation ID. Now we'll be really boring, and we will just create it as. We could do a string, but correlation ID has this meaning to it. I want to prevent myself from accidentally treating a string as a correlation ID. So I'll do this in Scala. Correlation ID, value containing a string. OK, so I have a case class with that name, so that I can box a string into a correlation ID. Now, boo, inefficient. It means that for every string, I'll be creating a correlate, another object, another instance of this correlation ID. Now, what I can do is say this extends any val. Now, that's quite useful. It means that I can treat correlation ID as its specific type, but it doesn't get boxed. The bytecode will actually contain the underlying thing, the value. OK, enough talking. Let's just do an override def to string. I just want the value, like so. All right, so we have these basic things. What I can also do is implement this recog service activator. That's the component that will be called when message arrives. Remember the flow. Recog service, messages arrive here. That's the entry point. Magic will happen, ponies, unicorns, and all that stuff. And then this thing will get called. Rather, implementations of trait recog service activator. Now, what I want in the recog service activator is just the onCoins response method. All right. Taking the ID, correlation ID, coin response, or other coins maybe, returning a unit. Excellent, right? That's all I have. So implementations of this will do something interesting for me. Now, what we need to now do is implement the recog service. Now, who remembers what we need? For this to work, for us to have a chance to send messages out, Spring integration people, what do we depend on? What do we need? How do messages go out? Channel, that's right. Absolutely, we need a channel. What are we going to call it? Recog channel. It's a message channel. Excellent. Now, all that we're going to do here is prepare a message, right? That's going to be really easy. Now, I could do the typing, but I'm going to cheat. And you can cheat as well. If you clone this repository, you can follow every step of the talk. So I'm going to say grol next. So this is ever so slightly cheating, you see. There's no way I would have typed in this Java doc in such a short time. But in any case, here's what happened. We added the recog channel dependency. So construct a parameter. When I'm creating an instance of recog service, I need to supply a message channel. Great. And then body of image chunk and MJPEG chunk, simply create, use the message builder with payload containing the chunk. So this lot gives me a message builder containing an array of bytes, or rather chunk data. We set the correlation ID. We specify the content type. We call build, which gives us a message, Spring integration message, send it on the direct channel, and we're done. Nice and easy. Fantastic. So we have recog service activity. I can do a TV news. There you go. Thank you. Brilliant. OK, so chunk decoder. We have a component that decodes these messages. So what do? This is the intermediate step. It hits our chain. what do we do with the chunk data? Well, we need to sort of split it up, right? So nothing could be simpler. Here it is. Chunk decoder. Again, taking an mjpeg decoder. I will not get into mjpeg decoder. That's not part of this talk. You can have a look at the source code. It's actually really easy. But anyhow, here is the method that will be called a decode frame. So what we would like to receive from Spring integration, remember this is the correlation ID header. So add header param, nothing too funky, nothing new. I know it's going to go to RabbitMQ and C++, but this is fine. Content type and the payload. And we will pattern match on the content type. So think of this as an if statement. So if the content type is video MJPEG, then we'll decode MJPEG frames. If the content type is image star, as I invented, then we will decode a single image. This method, of course, returns a collection of image data. So we go from chunk data. Remember the diagram? I'll switch to it just very quickly. We go from chunk data into a collection of frame data. That's our decoding process. One bit of data from the iOS device into potentially multiple frames that will go on to RabbitMQ. So we're here, right? Chunk decoder. Nice and easy. Excellent. So what next? What next? Well, now we need to somehow send it over the RabbitMQ. What do we do? How do we actually connect it? Any ideas? What would you do if you had to now continue, connect to RabbitMQ? What's the next component? Create the channels? Yes, that's right. That's right. That's right. That's exactly it. What we need is a little bit of XML. I know, boo. But unfortunately, here it is. So what do I need? I will create a chain, because I don't want to create these intermediary channels. So the best thing to do is to create a chain. So here's roughly what it's going to look like. A chain. Now, what do we need first? We will need to have an activator in the diagram. So it's the activator that does the chunk decoding. Then we need a splitter. Then we need an AMQP outbound adapter. Then we need a toString adapter. And then we need another service activator. Exactly what this says, right? Look at that. Service activator, splitter, outbound endpoint, object to string transformer, and another service activator. So I could do the typing, but then again, what's the point in that? So there we go, chain. This is a bug in IntelliJ IDEA. I've already complained, so don't worry. I'm sure it will be fixed. In any case, input channel on this chain is our recog request direct channel. And then we have a service activator, where we call the decode frame method of the chunk decoder bean. Then we split it. Then we send the split messages, this is frame by frame, onto the sogx.exchange. So Spring 1 to GX. I didn't want the number 2. It just felt weird typing it. And we're using direct exchange. So we are specifying a routing key. We want to know which queue this message is going to go on. And then we'll have multiple consumers at the end of the queue. What we need to remember is to include all the headers, because we need to know what the correlation ID was on the request, so that when it arrives, I can pick it up again. So that's quite nice. That's really, really good thing to do. And an AMQP template. These are like the standard Spring components. JDBC template, Hibernate template, REST template, all these things follow the same pattern, which is defined ever so below. Recog service activator final component, right? So message arrives, object to string transformer, and activate the recog service activator. Great. So how do we connect to RabbitMQ? 2 lines of XML. You can see them right there. So I need a connection factory. This is a Mac special, right? Host is by default localhost, unless, of course, you have a host name set on your machine, and unless you're using your special Wi-Fi dongle, in which case it doesn't resolve. So just a bit of a trick. Don't forget, if you're running on localhost, say localhost. Otherwise, it won't work. That took a long time to sort out. At exactly 8:10 in the morning, thinking, oh no, it stopped working. Anyhow, and then I have an AMQP template, which connects to the connection factory, and that gives me my connection to RabbitMQ. So that's all there is to it. So this seems nearly ready, right? We're almost good to go. So let's implement a little command line application that I can use. Let's close all these things. I have a class command line interface. So what will I need? Oh, well, this is depressingly empty, some commands. I'm going to have to create a Spring application context, Java config, boot up a generic XML application context, get the bean, and do the image processing. So let me just not type. That would be terrible. This is what it is, right? So look at that. Nice and easy. Core config contains all the beans. This is Java configuration, nothing too funky. Look at that. I have the mjpeg decoder bean. This is standard Spring 101. You all should be saying, Jan, just forget it. We know. Now's the time where you say, forget it, we know. OK, great. These are the things. So what is interesting, though, is the async executor and recog service activator. We don't provide implementations of these. This is for others to do. So if you implement this trait, which is sort of like the interface with defender methods in Java 8, even though they're no longer defender methods, there's some new name that Oracle has invented. In any case, this is, think interface with implementation, right? These are actually implemented methods. They're not abstract methods. But I have two methods here that aren't implemented. And it will be the job of whoever uses this to provide them. When it's a command line application, you see, the executor will probably be a sync executor. I don't want to, this is command line, right? No multiple users, just a single user. And the recog service activator will just do a print line. Nothing more than that. It's the web app that will do more interesting stuff. The web app will do messaging over WebSockets. Why not? Anyhow, and then I have the channel, recog request, which is quite simply a direct channel. Really simple. I think this is 8 beans. I have counted them. It could be 7. One could get lost. Anyhow, and then I have a class app, add configuration, add import resource, usual Spring business. This shouldn't surprise you. And I implement these two methods from core config. So I need to implement method async executor, returning executor. In this particular case, it will be a sync task executor. Doesn't do anything. This is command line app. We wait. And the recog service activator, we will give an implementation of the recog service activator trait by implementing the onCoin response method by doing print line. If we were proper, we'd logged into RabbitMQ, but one step at a time. So I guess I can run it, right? So just press Command, Control, Alt, Delete, F10. Wait for it to do something. Now this is where we get the compile errors. Oh, the horror. Oh no, it's running. Warnings, that's OK. Who cares about warnings anyhow? So we can send commands. So we can read this mjpeg stream. So I've implemented a little reading thing, coins to mjpeg. So I can find, when I type that, I'm going to be calling the methods, as you can see here. I'm going to be calling the methods of the recog service. I'll be sending mjpeg chunks or image chunks. So let's do that. Go. Fantastic. Look at that. There it is. So take my word for it. This is some video that we're seeing running in the background. Nothing to it. This is the actual response that we received from RabbitMQ. Look at that. So it says, OK, there's no ring, and there are coins. There is a coin with a center position, 702, 503, with a radius, and another coin. And the whole thing has indeed succeeded. So this was a message that came from our Spring code, got decoded, chunked, over to RabbitMQ, direct exchange. We've done some C++ code, received response, and printed it out here. There was a question on RabbitMQ console. There is one indeed. Let's see this. there it is, right? So this is what an admin interface looks like. I have my exchanges, as we can see. Where are we? Exchanges, sorry. Here I've created one, sogx.exchange. It is a direct exchange. And I have a queue. And the queue is called sogx.recog.queue. So a bit of a mouthful for a name. In any case, here's what we can see is happening. There are no messages now. We can just about see the tail end. Let me send another one. That'll be fun. mjpeg coins to mjpeg. Boom. Now, if we refresh, we can see that messages are coming in. There you go, 1.2 messages per second, 7.4. I'm pressing refresh, so it's not exactly real time. But this is what we're getting. Messages are arriving from our Spring app, being consumed at the end by the C++ code, and messages are being replied. There we go, so it drops off to 0 again. We can see the binding and consumers. So when Alvaro was drawing the consumers, he drew just 2 or 3, if you remember the diagram. Here we have 8, because I can have the C++ code creates an app with 8 threads. And each thread represents a consumer, and we can receive messages. So why 8? Well, this has 8 cores, and we're running the CPU version of the code. So brilliant. I can receive 8 messages at the same time and do the processing, one in each thread. RabbitMQ will take care of round-robin routing. And if my C++ code isn't that brilliant, so what I would normally do is run multiple instances of this C++ code. So if one sec faults, that's kind of OK. We can restart it again with a little shell script. Everything ultimately can be replaced with a little shell script, including programmers, right? Now, binding. So there we go. A message arriving on the SOGX exchange from the Spring code, send it to SOGX exchange, using sogx.recog.key. So that's the routing key. That's going to be delivered to this queue. If I click unbind, bad things would happen. Namely, my Spring app will stop working because the messages will not get delivered. So that would be a terrible thing to do. I could also kill the C++ program, like so, and try again. Coins to mjpeg. Yeah, that's not really good, is it? No messages. So I'm sending messages. They're being queued up, but no one's consuming them. So I have these messages stacked up. No one was there to eat them. And I actually specified a timeout on my chain. It says, if a message is not received within so many milliseconds, complain. This is an error. There's nothing we can do other than, of course, run our C++ application. So here we are. We have a command line app, which is, it's all right, isn't it? But it's not brilliant. It's OK. It doesn't do anything too funky. Let me move to this point in our talk. If you noticed, I've already pre-prepared these queues. So when I opened up the RabbitMQ console, the exchange was there. The queue was there. The binding was pre-prepared. But the problem is, if you just install RabbitMQ and start the app for the first time, it will be empty. So that's not going to be good. Now, what Spring provides is RabbitMQ admin, which is sort of a convenience, laziness option. So you can actually define configuration in your Spring XML that describes what should be seen in the RabbitMQ. So I can do just that. So in my Spring XML config, which is here, this is the empty one, right? That's no good. What I would like to do is to connect to the admin interface of RabbitMQ and actually get it to create the exchange, get it to create the queues, bind them if they're not present. So we can do just that, right? Rabbit admin. So this is the admin connection. We'll call it Rabbit admin. OK, that's not very, very helpful. It needs a connection factory, which we called connection factory. Brilliant. So that's that. Now, what I will want to define is a queue. So Rabbit
Just a detail while
Sure.
you type.
Oh, yeah.
The management API implements an HTTP API, so if you need to administer the RabbitMQ or add queues, remove queues, see the length of the queues, see if you have exchanges, if you have bindings, which users you have, which permissions each user has, the load of the system, if Rabbit is cluster, how many nodes are in the cluster, and so on and so forth, all is there in that management plugin. You have the HTTP interface, which is what Jan has been showing, and then you have the HTTP API. The API is accessible also from the plugin, so you can see what methods accept, which one take a post, a put, a get, and so on. So everything is there provided by the plugin.
That's right. So just
Does the admin API have like credentials?
Yes.
yes, yeah.
Yes.
Absolutely. I'm not showing that here, but what you would really want to do is in your connection, you would want to perhaps specify the username, password. And generally, you wouldn't want to have just one host.
Yeah.
Right? If you're talking scalable architecture, you don't want just one RabbitMQ, because if that dies, then that's it, you're done. You would want addresses. So this would be a list of RabbitMQs, list of addresses of multiple RabbitMQ brokers that the messages would go to with a particular failover strategy.
Yeah,
For now, localhost is good enough, but
it's
go,
good enough.
Alvaro.
And with plugins also, RabbitMQ provides many authentication mechanisms. So there is plain, SASL, you have all the SSL stuff, you can add LDAP. I mean, there are many ways to authenticate your users, and you can even extend with new ones. So, yeah.
Absolutely. All right, so here we are. This is all the XML typed in. So this means that when you run this application in Spring, it will automatically create your configuration for RabbitMQ. So if you clone this whole repository and get everything building, you run the Spring app for the first time, everything will be created for you. No need to do anything. If I didn't, let me just, no, I won't. That's a bit too dangerous. With 20 minutes to go, I wouldn't want to push it. What I can show you is this, right? Suppose I kill RabbitMQ and I run my C++ code, it will be deeply unhappy. So the error handling, leaves something to be desired. So this sort of thing is deeply unpleasant. Yeah, uncaught exception of type standard runtime, socket error. I mean, you can just about decode it. It essentially says, look, there's no RabbitMQ, so I need to have it running. I invite you to improve the C++ code. So let me start that again. It takes just 1, 2, 3, okay, 10 seconds. This is embarrassing, isn't it? We should be up and running any time.
Okay.
This was probably not a good idea to do. It tries to resolve all the local names. Anyhow, so here we are. Command line app. Who's happy with a command line app? In 2013, okay, one. There have to be two, right? Come on. So, yeah, absolutely. Naughty step. That's right. Okay, let's do a web app. AngularJS, Stomp. We do want to use Stomp because it's just a pleasant way of communicating. And we want to then use binary WebSocket messages. So all that code is coming to Spring Framework. This one for the iOS stuff, there's a pull request for it. So I haven't actually looked at it because I want to keep this code safe. But it'll be there anytime soon. Right, let's do it. What we need is a configuration for the web app, a simple web app structure. Let's start with that. We want to have multiple recognition sessions. So this is now multi-user business, multiple phones. So a simple class that contains just an in-memory store of them, a hash map, mapping a session ID to the actual JSON that we've received. Nothing could be simple, right? Recog sessions. I might even have a slide. Hang on, I have a slide. This is exciting. Look, that's what we're building, just so you know. But you would have easily followed it if I typed. So all that we're doing, this is the same business. This is what we had on the command line app. Recog service, RabbitMQ stuff, Recog session activator. Brilliant. We're going to replace the implementation of Recog service activator by one that sends messages to Recog sessions. So instead of printing them out on the standard output, we'll put them into this map. So I can tie together session ID with the actual response. And on the receiving side, I'll have a recog controller. So this is a standard Spring MVC business. Message comes in, and I will call the method of the recog service, just like I've done on the command line app. Nothing too complicated. And we hope that everything will work, except the exciting part will be the message sender. This is part of Spring messaging. So if you went to the right talks, and if you listen to Adrian's keynote, you will see the messaging is sort of taking bits from Spring integration and moving some of the message sending operations into the core of the Spring framework. So this will be really exciting. This is how we're going to wire in a WebSocket. And finally, this is what it's going to look like. This is the whole deal. This is a whole complicated business. There is some sort of lions and beasts here for the Spring MVC stuff. I'm sure you know all of that. Dispatcher servlet, and annotation handler adapter, annotation handler mapping. No need to worry about that. But here's the interesting stuff. Recog sessions, recog service. So there's this RabbitMQ connection. So a message arriving, a chunk arriving into a recog service will slowly find its way to recog sessions ultimately. Now, we will use the message sending operations to send a message. We have two channels, two messaging pipelines in our app. This one that deals with the WebSocket side of things. So when a message arrives onto our WebSocket handler channel, it will go out using the sub-protocol WebSocket handler, which handles the stomp messaging. And we'll have a dispatcher servlet, and somewhere here, right, would be the AngularJS app. Internally, all the messages from recog sessions, okay, careful with that, they arrive onto the subscribable channel, the dispatch channel. From that, we will pick them up by the simple broken message handler and the annotation message handler that's going to look at the contents of the messages, look at the destination, and then potentially deliver them again over the WebSocket. And when a message arrives from the iOS client, it will hit our messaging WebSocket handler, which will deal with the binary WebSocket, and it will send a message through message sending operations into our internal message bus of the application. It's going to get picked up by the annotation message handler, which knows about the recog controller, which is going to send the message to recog service, RabbitMQ business, all the way to recog sessions at the top, and the same message flow from there. So this will actually be, looks complicated, but it will be about 5 beans in total, maybe 6. How hard can that be? Right, let's do that. So recog sessions. What we will need is this message sender, we called it. Did we? Well, what's my name? Sender, yes. It is an instance of simple message sending operations. All righty, so we need a map of sessions. Sessions is simply a util hash map containing a session, recog session ID even, and coin response. That's the one. That's that. And then we have, just borrow that so I don't, in fact, I will cheat yet again. This is horrible. Just so I don't have to do this. There we go. That's more like it. So a util hash map containing a recog session ID, which is just another string. This is the session we maintain from the WebSocket side of things. And a coin response is our type alias for string. Nothing too complicated. On coin response, so when we receive a coin response for that given correlation ID, we will generate a recog session ID. We'll pick up the value, underlying value of the correlation ID, because we say that correlation ID and session IDs will be the same in our system for this particular app. Put in the coins, and we'll do this, send sessions. This is the interesting bit, right? So this is where we use the message sender, and we do convert and send, and there's going to be some sort of magic. So let's see what this magic is. That's the important stuff. Alvaro talked about topics. Well, we're going to do the same thing. You see, our AngularJS apps will be subscribing to this topic. And so whenever a message arrives on that topic, we will want to do something. And that's something we will see in just a minute in our AngularJS app. And what we're going to send is just the values of all the sessions, so that array of strings. They'll go over our WebSocket infrastructure, and it will hit our web app. OK, excellent. We need a controller. So this is also relatively simple Spring MVC stuff and Spring messaging stuff. Remember the diagram where I showed that the message buses, WebSocket bus and the internal messaging bus, they all handle the messages in a very, very uniform way. Specifically, the annotation message handler and the annotation handler mapping, they work in the same way. So they are aware of all the controller beans that I have in my application. And so I can have methods with the usual request mapping. So I have a little cheating pre-def recordings that I've taken just in case we couldn't get things working here. So as a pre-def, these are just standard HTTP requests, plain old controller methods. And then I have these two methods that have message mapping annotation on them. So this is when a message in the Spring messaging infrastructure arrives. So a message, say, from a WebSocket. Then these will get triggered. So I have a message mapping on app recog image, and I receive a session ID, and I receive a body. Now, the annotations are ever so slightly different, a session ID and an @message body, which are very similar to what you would have in Spring integration. And all that we're going to do is call the image chunk and the mjpeg chunk method of the recog service. Yes, this flow. Recog controller knows about the recog service. The recog service will eventually sort of process the messages, and they will hit our recog sessions class. And from recog sessions, again, simple message sending operations through the annotation, through the simple broker message handler, over to WebSocket and out to our web app. All right. So I think we're pretty there, aren't we? So we have the controller, we have the recog service. Come on, Spring people. What else? What else? What else? I suppose these need to be beans, right? And sadly, they are not just yet. So we need to create all the configuration for the web app. We need to create the task scheduler, the one that we created as a synchronous one. Now we need a slightly complicated one, maybe a thread pool one. We need to create the sock.js handler mapping. We need to create a raw WebSocket mapping. So there's quite a bit of typing. So let me just do that with Javadoc. It's amazing. I wish I could do that on all of my code. If anyone wants to contribute to this wonderful project, that would be great. Some sort of AI. Next. Anyhow, so web config. We need a WebSocket handle channel. Remember, this is one of the first subscribable channels in our configuration, the WebSocket handler channel. So messages arriving on that channel will be routed either in or out through the WebSocket interface. Then we need a task scheduler, which will do things like liveness ticks and immediate responses to the WebSocket Stomp infrastructure. So this is, are you still there? Ping pong. But we need a thread pool to be able to do that. Then we need a simple message broker. So this is the thing that will receive messages and will send them out over WebSockets. And we will we'll provide two URLs, if you like, topic and queue. So if you remember, we sent message out onto the topic sessions. So I can have multiple subscribers to that topic. If you wanted to do point-to-point messages, you would probably pick a queue. There's actually no difference in the code that you see here. It's just for humans to understand that if you say queue, you probably want point-to-point. If you say topic, you want one message and multiple subscribers that want to listen on that topic. I map the sock.js and the raw WebSocket to URLs. So here's my sock.js handler mapping. So this is a sub-protocol handler. It's a brand new thing in Spring 4. So have a look at that. It's brilliant because I can use the stomp protocol. So stomp isn't just RabbitMQ job. It's a very, very useful protocol that I can use from my WebSockets. And it just so happens that sock.js is another creation from the RabbitMQ team. So there is a JavaScript client, if you like, that I can use to connect, to use the protocol. And I can have code in my Spring app that understands the stomp protocol and can handle things. I also have this thing, which is a raw, really, really fairly stupid WebSocket connection. I want to be using that from my Objective-C code. I want to establish WebSocket connections. Again, all the code is there. We won't do Objective-C. That's a bit too much. In any case, you can open a binary WebSocket connection to that URL. And again, through this messaging WebSocket handler, it will be aware of all the controllers in my app through the message channel. And all the methods of the controller will be called. So nothing too complicated. These methods. Recog's controller. So image and mjpeg. So when a binary WebSocket message arrives to app recog image containing a session ID, the WebSocket session ID, and here's the body, the chunk data, this method will be called. And what do we do in that method? Well, nothing too complicated. We just call the image chunk and the mjpeg chunk method of our recog service. Excellent. I think that's pretty much it. And then annotation message handler, that's the bean that is aware of all the controllers. When a message appears on one of the channels, it knows about all the controllers. It converts the message, if necessary, to match it to the method, to the argument types of the controller method. And we subscribe to the dispatch channel. So this is the annotation message handler that subscribes to the dispatch channel and is aware of all the controllers. OK, I think this is nearly it. This is amazing. Look at that. And we have time. So let's run it, right? Let's see it. You can probably guess that this won't work. Compiling, thinking. Right. Something's happening. So we should possibly, if it all runs, artifact is deployed successfully. Well, that's a good start. Local host 80 sessions. Oh, well, that's no good, really. What's missing? You know, what's happening? I mean, really. Oh yeah, one of those. So remember, Spring Web App, we need to initialize the dispatcher servlet. This is an XML. I have no web XML. This is the first time I've done that. I felt weird, right? No web XML. It's amazing. So I need to create a dispatcher servlet, and I actually need to say where the web app is going to be configured. So here we go. The dispatcher servlet. So what does it need? Well, I've created this web app file, which was just like the command line app. So it is add configuration. Yay. Add enable web MVC. We do some component scanning to discover all the controllers. We create the async executor and the recog service activator because we need to implement them just like we've done it in the command line app. And we implement them by providing a recog service activator that on coin response puts the response onto the recog sessions. From there, over WebSocket to our web app. So this is nearly it, isn't it? So what do we need? What do we need? What else do we need? Let's see. I suspect there's going to be some sort of, oh yeah, there's that, right? It's this unpleasant business of HTML. Now, again, let's cheat a little, right? I don't want to be typing HTML. What I have done, though, is prepared plenty of JavaScript. So the interesting stuff, the really interesting stuff, of course, is here. We'll deal with that HTML in just a minute. So I create a sock.js instance, and then I instantiate a protocol, if you like, a stomp over that WebSocket. So now I can connect. So this gives me a stomp client. I can connect supplying a username and password. I'm fairly liberal, as you can see. No, never mind username, password. It's a demo after all. And I have my firewall enabled, just for good measure. When the connection is established, I subscribe. See, this is the interesting stuff, right? I subscribe to the topic recog sessions. So when a message arrives on that topic, this is going to happen. I will set the sessions model attribute to parsing, I'll JSON parse the body of the message. And then that's that. That's all there is required. All that we need is a little bit, tiny little bit, of HTML. Like that. This is the AngularJS demo. If you go on angularjs.org, they'll show you this, and you'll think, oh, wow, this is amazing. What I have done in addition is I've written a little custom canvas. So what I can show is canvas display squiggly, squiggly coins. So that's going to actually draw all the coins from the JSON on a canvas. So I think now's the time to actually see the grand finale. This is the most stressing part of the whole talk. Let's run this. No, hang on. I want to run the recog component. So that's running. RabbitMQ running. Web app restarting. I think we're looking good. We think. So let's see. Artifact deployed successfully. Right, no more stalling. Oh, right, excellent. So here's my app. So remember, I had those cheating things. Localhost, app, pre-def, coins. So this sends the pre-recorded video. Here's what it looks like. Brilliant. So I receive the messages. So this is doing the recognition, messages through RabbitMQ. As you can see now, we were receiving messages. We had a WebSocket subscription to that, and that all worked beautifully. Now, OK, so that's how I'm pre-def. Come on. So we have this thing. We have a couple of phones, a couple of iPads, and we have some coins. So what I can do is run this app, which is the same thing. I have a pre-recorded video on it. Right, so I can press a pre-def button like that. There you go. So this sends the video pre-recorded. Nearly, come on. No, not yet, not yet. All right, here's the big deal. So actual video. Let's have one, second one, and a third one, and we'll be moving them around. So that's all fantastic. Nearly, except, it's sort of hard to believe. Can you take my word for it? Of course you can. There it is. It's brilliant. Yay. Now, why did we do all these sessions? I have a completely random member from the audience. Guy, come on up. You can tell this was completely unprepared. So let's do another one. So we have one session that's running there, and he started another session. There we go. So we're now having too much shady. Focus on these two. There we go. So we have two sessions, both on the same computer. The OpenCL version will handle
we need your coins to see that.
Yeah, we need more coins. OK, not just yet. All right, so let's do one more thing, right? Almost there. So thanks for now. Let's do one more. Now,
Thanks.
What we want to see. So Alvaro was talking about this sort of live update. This is the cool stuff, right? This is why you would do an app. So I'll just stop the session for now. I could have left it running anyhow. Now let's count coins in a slightly different way. So what we're going to do is slight modification to the CSS. So I'll show you the HTML. You can probably figure out what that's going. No. What that's going to do. So look at that, div ID Mordor. Now, OK, what could that possibly be? And then ng class coins is true, glow. Well, all right, this will be reasonably interesting. So let's see this. Same code, right? Yes, it would help to update resources, wouldn't it, to actually deploy it. All right, there we go. Wow. Righty. Now, we can do the same thing. So I'm going to take one phone. Just one will do. Start a session. There we go. So 2 coins. OK, well, thing is, right, if you're a motor dollar, you're probably looking for a ring. Now, the problem is it won't quite work. Right? This is just another coin. So what we want to do, we've prepared another version of the binary. So there's another version of this C++ code, which contains the ring recognition code. So what I can do is run it. I'll keep the old one running. That's still there. And I've just started a new one. This whole thing is still running. Right? No problem. Still there. Except this one sees a ring. Now, the problem is, of course, some of the messages are being routed to the old version of the binary. So all that I'm going to do is make a tiny little tweak. I forgot to say toString here, but that's all right. So let's do a final start. This is my fault. This should have worked in a far better way. So I have, let me show you the RabbitMQ management console. Connections. Look at that. I have 2 of these connections. So one from the old app that doesn't detect rings, and one from the new version of the C++ code that detects rings. RabbitMQ will do round-robin routing. Right? So message, first consumer. Second message, second consumer. Third message, third consumer. Now, I don't know which one is which. So that's a bit of a bum. But I have both of them running. So if I refresh this, no. There we go. So do this again. Where are we? Come on. There we go. So some of them, look at that. Some of them actually do see the ring, but some of them don't because they go to the old C++ app. So all that I'm going to do now is select the old one, thank you, and simply kill it. So now I have just the new app running, and there it is. Ring gone. OK, happy. Ring back in. There we go, all working. So by all means, give it a try. I'll keep it running for a bit. It's great fun. And well, what do I have? 2 more slides. Questions. First question, where is the source code? Here. So you can download the source code. And if you follow the scroll next, you can replay all the steps in the talk. So you can try to type some of that up. It's all described. There's a big markdown file that you can follow. If you get stuck or if you don't want to do the typing, just scroll next, scroll next, scroll next, and it will take you all the way to the end of the talk. Building instructions, you'll need Erlang, you'll need C++, you'll need OpenCV, you'll need all sorts of. It's good exercise, right? And over to you. Yes?
I was told, I don't have much information about it, but my team wanted to use RabbitMQ, and when we have a hard requirement to use amqp version 1, and it seems like RabbitMQ does not support it.
OK, the question is if RabbitMQ supports amqp version 1.0. It does via a plugin. And you can get it on the website or on the default distribution of Rabbit. You have amqp 1.0, 0.9.1, and 0.8.0, I think. So the plugin comes directly with the distribution of Rabbit. So you just need to enable, and that's that. Yeah. By the way, I don't know how much time we have for questions, but in my case, for RabbitMQ, I will be from 12 to 1 p.m. at the Pivotal booth there answering questions. So if anybody wants to really know stuff directly about Rabbit, I will be there.
I'll be there as well. So if you want to have a look at the thing running again and poke it, examine the details, by all means, jump over there. One more.
Where is this demo application? Is this out somewhere?
It's on GitHub.
It's on GitHub. Clone the repo. Unfortunately, you have to build it yourself because of all the componentry. If you're running on a computer with OpenCL, you build it with OpenCL, so with OpenCL, and that will give you an OpenCL build of it. One more?
When we're talking about queues, there's always this holy grail of performance. So, do you have any performance benchmarking RabbitMQ against RabbitMQ, for instance, or Spout or something like that?
Against which one, sorry? So there are different queuings. The question is, what's the performance? Yesterday night, particularly, I was trying the performance of Rabbit with a very vanilla Java producer. In this MacBook, I was sending 30,000 messages per second. That's what this can do. You can tune Rabbit a lot. You can have in-memory messaging. You can have messages persisted to disk. You can get confirmations if the message was persisted or not. Every step will slow down the stuff, but you will get more guarantees about the messages actually not getting lost. If you add highly available queues, that is mirrored queues across many brokers, then you will have slower responses and so on. I mean, there is no magic. The more in memory you go, the faster you will go. There are queues out there or libraries that are in memory only, but they are not doing a broker-based solution, and there are different use cases and different tools for them. We don't like to enter into who is faster, who is what, because every benchmark will show which one is the fastest. I remember lately, like this beginning of the year in Hacker News, there was one where RabbitMQ was the fastest one. Then the guys from the other queues were like, no, but this is wrong here, there, and there. So benchmarks. I only trust them if I run them.
Yes, absolutely. It all comes down to what your app is. So in this particular one, we've built it very, very trivial. We don't even require an acknowledgement of receiving a message, because we say, look, this is a 25 frames per second video. If one gets lost, doesn't matter. Another one is coming in 25 milliseconds. So we don't acknowledge, we just sort of dump them. So it means that we will potentially lose messages in this app. So if a component cannot consume them quickly enough, it just disappears, it's gone. And if the processing fails, then the broker will never retract the message and try to resend it again. In probably financial applications or something a bit more serious, you would want more guarantees. So you want acknowledgement, meaning your component has done processing the application and acknowledges to the broker, and the broker says, OK, fine, I'm done. I can see that this now worked. In this app, if one of our threads failed, the message would have been lost. So not great. But then again, we get the performance. For this particular app, we don't care.
Exactly. Yeah.
All right. If there are no more questions, well, thank you for your attention. Hope you enjoyed it.
Thanks.